its converse, and the Pythagorean inequality theorem. So we talked about the Pythagorean theorem with the distance formula just because that made the most sense, but now we're covering it and its converse. So if a triangle is a right triangle, then the sum the sum of the square of the two smaller sides, that's what's shown here. We add the two smaller sides squares together. That equals the largest side squared. Its converse says that if that's true, if this equation holds true, if the sum of the square of the two smaller sides equals the square of the largest side, then the triangle is a right triangle. So it's really just that statement backwards. So we can show that a triangle is a right triangle if it holds in this equation. So we can use the Pythagorean theorem to find a missing side. We can also use it to justify that a triangle is in fact a right triangle. So a right triangle has two side lengths of 25 and 60 meters. What's the length of the hypotenuse? That has to be c in that equation. A squared plus b squared equals c squared. The hypotenuse, or the longest side, is always going to be c. So we're going to do 25 squared plus 60 squared. That equals c squared. So 25 squared is 625. 60 squared is 3,600. Those two added together is 4,225. That equals c squared. We really want to figure out what c equals, so we're going to do the square root of that side, and that equals 65 meters. So that's the most straightforward example, where you're given the two short sides, you add those together, you add those squares together, and you take the square root of that. That tells you c. Now we're going to justify if this is a right triangle or not. So we're going to do a squared plus b squared, and we're going to see if it equals c squared. 9 squared is 81, 12 squared is 144, 17 squared is 289. Those are not equal to each other, so no, that is not a right triangle. All right, here we're going to really have to use Pythagorean theorem a couple times. We're looking for the length of the diagonal of that rectangular prism, the distance from there to there. So we have to figure out how to set up a right triangle here. So I'm seeing a right triangle cutting across there, where that dashed line, that diagonal, is the hypotenuse of that right triangle. So if I can figure out this side, I already know this leg. If I can figure out that side, that would be the other leg. And the way I'm going to do that is using the right triangle at the base of this rectangular prism. That is a 9 by 8 right triangle, where I'm going to say this is my B, this is my A. I'm always going to just do it in order from least to greatest, so that's my smallest one. That's my second smallest one. It's supposed to be a plus sign. And that equals, let's just call that X. That's the hypotenuse of that triangle. So 64 plus 81 equals X squared. We're going to do the square root of that to figure out that side is about 12. It's 12.04. Now that is one of the legs in this triangle, where the hypotenuse is a diagonal. So I'm going to use that as, I'll call that my B. I'm going to say A squared, that's 6 squared, plus 12.04 squared equals, let's call that y squared. So 36 plus, really I'm just going to use 145. I mean, if I round this to 12.04, it's not going to give me exactly 145. But I know I just took the square root of 145 here to get down to that number. So squaring it gets me back to 145. And then I'll do the square root of 181. We could actually just leave our answer like this. If we want to simplify that radical, we can't. Or if you'd like to write it as decimal, you could also write that y equals 13.45. We're okay with decimal answers, or just leaving it as a simplified radical. I'm actually going to set up 2 of these U-try questions, 2 and 4. I think I at least want to show you how to set those 2 up, and then I'll let you try really finishing those and doing the other 2 on your own. So I'm trying to find the length of x here. That is one of the legs of the triangle. The hypotenuse has to be that one, so that has to be our C. I'm going to say that this is A, and I'm going to call that one B. So square root of 3 squared plus x squared equals 3 times radical 6 squared. So that would be 3 plus x squared equals, the way we square this term, you really kind of imagine this as distributing that squared into both of these. We square 3, that becomes 9. We square the square root of 6, that becomes 6. So really that is 54. We subtract 3 from both sides. We get 51 on the right side, and then the square root of 51 is the value of x. Again, if you want to write that as a decimal, you can, but you really don't have to. We could just leave it directly like that. That's a simplified radical. Or, if you'd like, as a decimal, that's 7.14. Either of those is okay. So I wanted to show you that one, because that one we're given c, and you have to work backwards to find either a or b. So the only difference there is that we're subtracting, because they're solving this equation for x, so you have to subtract the 3 from both sides, instead of just adding those two side lengths together. 4, I'm just going to help you set up, just because there's an expression here, and I want to make sure that when you plug it into that equation, you're substituting it in the correct way. So it shows the pendant in the shape of an isosceles triangle, and we have a right triangle on either side. So that side length of c is 13. I'm going to say a is really just x. It's half of that side length all the way across, so that has to be x. So x squared plus the b here is x plus 7. When you write this, it's the entire quantity squared. So you have to put x plus 7 in parentheses and then square that. I'm confident that you can solve that equation. You're going to keep going on that and then try those other two. All right, the Pythagorean inequality theorem will help us decide what type of triangle we have. So we're going to classify a triangle as either obtuse or acute, or we could say it's a right triangle if it's equal on both sides. But if they're not equal, it's either going to be obtuse or acute. If c squared is greater than the sum of the two small sides squared, then it's an obtuse triangle. And if c squared is less than the sum of those two short sides squared, then it's an acute triangle. I think a picture really helps here. When c grows too long, it stretches this angle. That stretches out. So c grows too big, and it can't be a right angle anymore. That means that it's an obtuse triangle. This angle became bigger than 90 degrees. When it's too short, when it's shorter than it's supposed to be a right angle, it creates an acute triangle because these rays, or these sidelines really, come together and make that angle a little bit smaller. All right, so we're going to take the two short sides, square them, 11 and 21, and see how that compares to 23 squared. So 11 squared is 121. 21 squared is 441. We add those together and we get 562. Whereas 23 squared is 529. So first off, they're different, so it's not a right triangle. Second, that c length, when we square that, that's smaller than the a squared and the b squared. So this is an acute triangle. We do the same thing here. My two short sides are my a and my b. Longest side has to be the c. We're going to square this, get 225, square this, get 400, and that gives us 625. Those are equal, so that is a right triangle. And the last example I'm going to do with you, I'm guessing you're going to figure out what this is already without having to actually do it. But looking at that angle, you might even be able to eyeball it, but this is important. We don't want to just look at that picture. You want to test it with Pythagorean inequality. So 2 squared plus 6 squared is 4 plus 36, which is 40. Since that's smaller than 49, that c stretch these side lengths to make that angle a little bit bigger than a 90-degree angle, so it's an obtuse triangle. So Pythagorean theorem can be used to find a missing side or classify a triangle as a right triangle. Pythagorean inequality theorem can show whether it's an obtuse or an acute triangle. All right, try the rest of this practice on your own.